December 17, 1944. The frozen fields outside Bastogne, Belgium, lay silent under fresh snow. Hauptmann Werner Schulze of the 2nd Panzer Division lowered his binoculars and studied the abandoned American tank sitting at the edge of a tree line, its engine still ticking as metal cooled in the bitter cold. His reconnaissance patrol had been tracking the retreat of American forces through the Ardennes for 3 days, and the evidence of their hasty withdrawal littered the landscape like discarded toys. But this tank was different. Schulze had commanded panzers since 1941, fought from the steppes of Russia to the bocage of Normandy. He knew American Shermans intimately, had studied dozens of knocked-out hulls, had read every intelligence briefing on their capabilities and weaknesses. Yet something about this particular Sherman's profile struck him as unfamiliar. The tracks were noticeably wider than standard models. The suspension bogies looked different, simpler somehow, less cluttered than the vertical Volute Spring Suspension he'd seen on other Shermans. As his crew approached cautiously, watching for demolition charges or American stragglers, Schulze noticed the hull designation painted in white stencil on the glacis plate, M4A3E8. The E8 designation meant nothing to him. German intelligence had documented M4A1s through A4s, variations in hull construction and power plants, but this E8 variant was new. Within hours, this single tank, abandoned intact during the chaos of the Battle of the Bulge, would be on its way to Kummersdorf proving grounds south of Berlin. And within weeks, it would force German tank designers to confront a fundamental truth about engineering philosophy. The Americans had solved problems that German engineers didn't even realize they'd created. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the paper world you are watching from today. The Sherman that Werner Schulze discovered that December morning bore the name Lucky 7 painted in fading white letters on its turret. It belonged to Company B, 37th Tank Battalion, 4th Armored Division, one of Patton's elite units racing to relieve the encircled American forces at Bastogne. Its crew had abandoned it not due to mechanical failure or enemy fire, but because they'd run completely out of fuel during the desperate advance through German lines. In the confusion of rapid movement and shifting supply lines, Lucky 7 simply ran dry and was left behind when the unit pushed forward on foot. German recovery teams found it undamaged, fully operational, requiring only diesel fuel to run. The Ford GAA V8 engine started on the second attempt despite sub-freezing temperatures, immediately impressing the German mechanics who'd struggled for hours that same morning to coax frozen Panther engines to life. Orders came swiftly from Waffenamt, the Army Weapons Office. This new Sherman variant was to be transported immediately to Kummersdorf for comprehensive evaluation. Someone in the German technical services recognized that American tank development hadn't stood still, and this E8 designation suggested significant modifications worth understanding. The journey from the Ardennes to Brandenburg took 6 days through a Germany increasingly paralyzed by Allied bombing and fuel shortages. Lucky 7 made the trip under its own power for the first 200 kilometers, then was loaded onto a rail car for the remainder when fuel became unavailable. Even this partial road march provided initial data. The tank crew assigned to drive it, veterans of the Eastern Front, immediately noticed something different about how the Sherman handled. It rode more smoothly than any tank they'd experienced. The suspension seemed to absorb terrain irregularities that would have jolted German tanks violently. The wider tracks provided noticeably better flotation over soft ground. Most remarkably, the gun barely moved in its mount, even when crossing rough terrain, maintaining its aim with minimal disturbance. Obergefreiter Paul Richter, the driver for that journey, filed a brief report that reached Kummersdorf before the tank itself arrived. This American machine rides like no tank I have operated in 5 years of service. The suspension is extraordinarily smooth. We crossed farm fields, shell-damaged roads, and rough terrain at speeds that would have damaged our Panthers. The Sherman absorbed everything without complaint. The crew compartment remained stable enough that the commander could observe through binoculars while moving, something impossible in our vehicles. I do not understand how the Americans have achieved this, but it represents a significant advantage in combat mobility. Kummersdorf in December 1944 was a shadow of its former self. Allied bombing had damaged some facilities. Fuel and material shortages constrained testing programs. Many of Germany's best engineers had been drafted or killed, yet the facility still functioned as Germany's primary evaluation center for captured equipment, and the arrival of this new Sherman variant received priority attention despite the deteriorating war situation. The tank was assigned test vehicle number 463, given the standard Vermich license plate WH09235-7, and moved into a heated maintenance hangar for initial inspection. The engineering team assembled to examine Lucky 7 represented the remaining talent of German tank development. Diplom-Ingenieur Heinrich Keller from Henschel, specialists in heavy tank design. Oberingenieur Franz Weber from MAN, builders of the Panther. Dr. Anton Fleischer from the Waffenamt's Suspension Development Section. And Hauptmann Ludwig Schmidt, a panzer officer with extensive combat experience tasked with evaluating tactical implications. What they discovered over the following weeks would fundamentally challenge assumptions about tank suspension design that had guided German development since the 1930s. The first comprehensive inspection began on December 23, 1944. German engineers swarmed over the Sherman, measuring, photographing, documenting every detail. They quickly identified what made this E8 variant different from earlier Shermans. The suspension system had been completely redesigned. Gone was the vertical Volute Spring Suspension used on all previous Sherman models, with its paired road wheels mounted on vertical coil springs. In its place was something the Germans termed horizontal Federungs system, horizontal spring suspension, though the Americans called it HVSS, horizontal Volute Spring Suspension. The new system was elegantly simple yet profoundly effective. Each bogie unit consisted of two road wheels mounted on a horizontal arm that pivoted on a pin attached to the hull. A large horizontal volute spring, essentially a massive coil spring lying on its side, absorbed vertical movement as the arm pivoted. The spring was mounted entirely outside the hull, accessible for maintenance without entering the vehicle. 4 of these bogie units on each side supported the tank, providing 8 road wheels per side compared to the 6 in earlier models. The tracks were dramatically wider, 23 inches compared to the 16.5-inch tracks on standard Shermans, nearly 40% greater surface area in contact with the ground. Heinrich Keller, whose career had been spent designing interleaved road wheel systems for Tiger and Panther tanks, examined the HVSS suspension with undisguised fascination. His initial assessment, recorded in notes dated December 24th, revealed both technical admiration and professional discomfort. The American approach is completely opposite to our methodology, where we pursue optimal weight distribution through complex interleaved wheel arrangements. They achieve similar results through wider tracks and simplified suspension geometry. Our system provides theoretically superior ride quality and ground pressure distribution when functioning perfectly. Their system provides adequate performance under all conditions with minimal maintenance. The critical difference is operational consistency. Our interleaved wheels perform magnificently on proving grounds, but present severe maintenance challenges in field conditions. Their horizontal spring system sacrifices marginal performance for dramatic improvements in reliability and serviceability. From a pure engineering standpoint, our solution is more sophisticated. From a military effectiveness standpoint, I must concede their solution is superior. The German engineers understood immediately why the HVSS represented such a significant advancement. The interleaved road wheel system used on Panthers and Tigers had always been problematic despite its engineering elegance. The overlapping wheels distributed the tank's weight beautifully, providing excellent flotation and smooth ride characteristics. But in practice, the system was a maintenance nightmare. If an inner wheel was damaged, the outer wheels had to be removed first, requiring hours of work even with proper tools. In Russian winter conditions, mud and snow would pack between the overlapping wheels and freeze solid overnight, completely immobilizing the tank until the crew could chip away the ice, a process that sometimes took an entire day. The HVSS suspension eliminated all these problems through brilliant simplicity. Each bogie unit was independent, mounted with 4 bolts. If damaged, it could be unbolted and replaced as a complete assembly in less than an hour using basic tools available to any tank unit. There was no interleaving, no overlapping, nothing to trap mud or debris. The horizontal springs were massive, robust, and nearly impossible to damage. The wider tracks reduced ground pressure significantly, improving mobility in soft terrain without complex engineering. The entire system embodied a design philosophy focused on field serviceability rather than theoretical perfection. Dr. Anton Fleischer, who had spent his career in suspension development, conducted detailed measurements and calculations. His technical report, dated January 5, 1945, provided quantitative analysis of why the HVSS worked so effectively. The American horizontal spring suspension achieves ground pressure of approximately 12 pounds per square inch, compared to 14 to 15 pounds per square inch for standard Shermans and 12 to 13 pounds per square inch for our Panther when its interleaved wheels are functioning properly. This gives the Easy 8, as Americans apparently call this variant, mobility comparable to our most sophisticated designs while maintaining far simpler mechanical arrangement. The horizontal volute springs provide approximately 3 3/4 inches of vertical travel, slightly less than our interleaved system's 4.5 inches. Yet, in practice, the Easy 8 suspension performs better in rough terrain because all wheels maintain ground contact more consistently. Our interleaved wheels tend to lift slightly during extreme suspension travel, temporarily reducing traction. The American system keeps all wheels planted firmly, regardless of suspension compression. Most significantly, the HVSS provides superior damping characteristics. The large horizontal springs resist oscillation effectively, stabilizing the hull during cross-country movement. This dramatically improves the gun's stability, allowing more accurate fire while moving. Our current systems permit excessive hull oscillation that degrades gunnery effectiveness during movement. The Americans have achieved through elegant design what we attempt to solve through complex fire control systems. The testing program began in earnest on December 28, 1944, despite freezing temperatures and snow-covered proving grounds. German test crews drove Lucky 7 through obstacle courses, across broken terrain, through mud and snow. They measured acceleration, top speed, turning radius, and climb capability. They documented fuel consumption and mechanical reliability. Most importantly, they evaluated the suspension's performance under conditions that would stress any tank. The results astonished even skeptical observers. The Easy 8 handled terrain that would challenge any German tank. It could maintain 15 to 20 miles per hour across country, speeds that Panthers could match only on roads. The wider tracks prevented the Sherman from bogging down in snow and mud that immobilized narrower-tracked vehicles. The suspension absorbed impacts from obstacles and rough ground with minimal disturbance to the crew or gun. Test drivers consistently reported that the Easy 8 was easier to control, more stable, and more comfortable than any German tank they'd operated. Hauptmann Ludwig Schmidt, the tactical evaluator, spent 3 full days operating Lucky 7 personally. His assessment, filed on January 10, 1945, came from a combat officer's perspective rather than an engineer's technical viewpoint, yet it confirmed what the engineers had documented. As a panzer commander with 4 years of combat experience, I can state without reservation that this American suspension system provides decisive tactical advantages. The Easy 8 maintains speed over terrain where our tanks must slow significantly. The stable ride allows the commander to maintain observation and situational awareness while moving at speeds that would make this impossible in German tanks. Most critically, the gun stability during movement is extraordinary. I conducted firing trials while moving cross-country at various speeds. The gun remained on target with minimal correction needed from the gunner. In a Panther moving at similar speeds over similar terrain, the gun pitches and yaws so severely that accurate fire is essentially impossible without halting. This suspension gives American tankers the ability to shoot effectively while moving, a capability we simply do not possess. In mobile combat, This is potentially decisive. The Americans can fire and maneuver simultaneously. We must stop to shoot accurately, making us vulnerable. The engineering team proceeded to disassemble one complete HVSS bogey unit to understand its construction in detail. What they found reinforced the pattern they'd observed throughout. The system was robustly designed using proven components manufactured to consistent standards. The horizontal volute spring was a massive coil of spring steel, simple to manufacture and extraordinarily durable. The pivot pins rode on bronze bushings that would last thousands of kilometers. The road wheels themselves were standard Sherman components, readily available and interchangeable. Everything was designed for replacement rather than repair. If something broke, you unbolted the damaged assembly and bolted on a new one. No specialized tools required. No skilled technicians needed. No complex adjustments necessary. Franz Weber from MAN, who had wrestled with Panther suspension problems for years, examined the disassembled bogie with an expression mixing admiration and frustration. This is exactly what the Panther needs and will never receive. Our interleaved suspension is a triumph of engineering, achieving exceptional performance when properly maintained. But it is completely unsuited to the reality of mechanized warfare, where maintenance time is limited and field conditions are harsh. This American system accepts slightly reduced performance in exchange for dramatic improvements in maintainability and operational consistency. From a military standpoint, this trade-off is clearly correct. We understood this intellectually, but never implemented it because our design culture prioritizes technical sophistication over practical utility. The horizontal springs particularly impressed German engineers. Each spring was a single massive component, impossible to damage under normal operation, requiring no adjustment, maintenance-free throughout the tank's service life. Compare this to the complex torsion bars used in later German designs or the multiple coil springs in the vertical volute system. The American solution was straightforward, effective, and foolproof. It embodied design principles that German engineers recognized as superior but found themselves unable to implement due to institutional momentum and industrial constraints. Testing continued through January 1945, even as the strategic situation deteriorated. Soviet forces advanced from the east. Allied armies pushed from the west. Germany's tank production was collapsing under bombing and material shortages. Yet, the engineers at Kummersdorf methodically documented every aspect of the EZ-8's performance, driven by professional commitment and perhaps recognition that this knowledge might matter in some future beyond the current disaster. The mobility trials provided the most dramatic demonstrations of the HVSS suspension's advantages. German test crews drove Lucky 7 in direct comparison with a Panther OSV-G and a Sherman M4A3 with standard vertical volute suspension. The course included paved roads, farm tracks, ploughed fields, wooded areas with obstacles, and a section of shell-damaged terrain deliberately chosen for difficulty. All three tanks started together and drove the complete circuit at maximum sustainable speed. The results were documented in film footage and written reports. On paved roads, all three tanks performed similarly, with the Panther slightly faster due to higher power-to-weight ratio. On farm tracks, the differences became apparent. The EZ-8 maintained speed and control, where the standard Sherman bounced and pitched noticeably. The Panther, with its narrow tracks, began struggling in soft sections. In ploughed fields, the advantage shifted decisively to the EZ-8. Its wide tracks provided flotation that kept it moving steadily, while both the standard Sherman and especially the Panther began labouring, sinking deeper, requiring more power to maintain forward progress. In the wooded obstacle course, the HVSS suspension's superiority became overwhelming. The EZ-8 flowed over logs, rocks, and rough ground with minimal disturbance to the hull. The gun remained remarkably stable, the crew comfortable, the tank maintaining consistent speed. The standard Sherman crashed over obstacles with violent pitching that threw the crew around and made the gun bounce wildly. The Panther, despite its sophisticated interleaved wheels, transmitted severe jolts to the hull as wheels impacted obstacles, and its gun waved around alarmingly. In the shell-damaged terrain, simulating battlefield conditions, the EZ-8 simply outperformed everything else. It absorbed the chaos of broken ground, maintained forward momentum, kept the crew functional, and most importantly, kept the gun stable enough for effective fire. The German observers watching this demonstration reached uncomfortable conclusions. The EZ-8 wasn't faster than a Panther on roads. Its armor was still inferior. Its gun, a 76mm M1A1 or A2, depending on variant, was adequate but less powerful than the Panther's 75mm KK-42. By most individual specifications, German tanks remained superior. Yet, as a complete fighting system optimized for actual battlefield conditions, the EZ-8 had achieved something Germany never managed. It combined adequate firepower and protection with superior mobility, excellent crew efficiency, and most crucially, extraordinary operational reliability. The HVSS suspension was the enabling technology that made this possible. Heinrich Keller conducted a detailed comparison between the HVSS suspension and the Panther's interleaved road wheel system. His analysis, dated January 18, 1945, stands as one of the most honest technical assessments produced by German engineers during the war. The comparison was not merely academic curiosity, but a desperate attempt to understand why German technical superiority was failing to produce strategic advantage. Our Panther suspension represents the pinnacle of European engineering tradition, Keller wrote. 8 interleaved road wheels per side, mounted on torsion bar springs, provide theoretically optimal weight distribution and ride quality. The system performs magnificently under ideal conditions on proving grounds with proper maintenance. In field service, it is a catastrophe. The interleaved wheels trap mud, debris, and snow. In Russian winter, tanks are immobilized for hours while crews chip frozen mud from between wheels. A single damaged inner wheel requires removal of multiple outer wheels, consuming 4 to 6 hours with specialized tools. Track tension must be constantly adjusted as the complex geometry shifts with wear. The American HVSS suspension sacrifices theoretical perfection for practical effectiveness. 4 independent bogie units per side provide adequate ride quality without the maintenance nightmares of our system. Each bogie can be replaced in under 1 hour with basic tools. Nothing traps debris. The wider tracks reduce ground pressure without complex wheel arrangements. The horizontal springs are essentially maintenance-free. From a pure engineering standpoint, our solution is more elegant. From a military effectiveness standpoint, their solution is categorically superior. We designed a suspension for peacetime evaluation. They designed a suspension for wartime operations. The gunnery trials provided perhaps the most tactically significant findings. German engineers mounted accelerometers throughout Lucky 7's hull and turret to measure stability during movement. They conducted parallel tests with a Panther and standard Sherman for comparison. The data confirmed what observers had seen visually. The EZ-8's hull remained significantly more stable during cross-country movement than either comparison vehicle. The HVSS suspension's superior damping characteristics meant the gun stayed on target with minimal correction needed from the gyro stabilizer. The Panther's gun, despite its superior ballistics, pitched and yawed so violently during movement that accurate fire was essentially impossible without halting. This gave American tankers a decisive tactical advantage in mobile engagements. They could shoot while maneuvering. German tankers had to stop, aim, fire, then move again, creating windows of vulnerability that skilled opponents exploited ruthlessly. Dr. Fleischer's report quantified this advantage. During cross-country movement at 12 miles per hour over moderately rough terrain, the EZ-8's gun vertical deviation averaged plus or minus 1.2 degrees, maintained within plus or minus 2 degrees 95% of the time. Under identical conditions, the Panther's gun deviation averaged plus or minus 3.8 degrees, frequently exceeding plus or minus 6 degrees. This represents more than triple the gun disturbance. At combat ranges of 800 to 1,000 meters, this difference means the EZ-8 can engage effectively while moving, whereas the Panther cannot. The strategic implication is profound. In mobile tank engagements, the side that can shoot accurately while moving holds decisive initiative. The EZ-8, despite inferior armor and gun, can dictate engagement terms through superior fire control during movement. Our tanks must sacrifice mobility for accuracy. Their tanks maintain both simultaneously. This advantage, derived entirely from superior suspension design, potentially negates our advantages in protection and firepower. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. The captured EZ-8 became legendary among test personnel at Kummersdorf during its months of evaluation. Test drivers preferred operating it because of its superior handling and reliability. Engineers used it as a reference standard in design reviews. Maintenance crews marveled at how little attention it required. In a facility filled with complex German tanks demanding constant care, the American Sherman, with its simple, robust systems, stood as a silent rebuke to German engineering philosophy. Oberfeldwebel Karl Hoffmann, a veteran tank driver with 6 years of service, operated Lucky 7 extensively during the testing program. His informal assessment, recorded in a letter to a friend that was intercepted by sensors, provided unvarnished perspective from an experienced tanker. I have driven Panzer IIIs, IVs, Panthers, even a Tiger during training. The EZ-8 is easier to operate than any of them. The controls are light and responsive. Visibility is excellent. The suspension makes the ride comfortable even over rough terrain. Most importantly, it simply works without drama or surprises. Our Panthers are magnificent when functioning properly, but they are temperamental beasts requiring constant attention. The transmission demands careful shifting. The engine overheats if pushed too hard. The suspension needs regular adjustment. The final drives fail without warning. You are always waiting for something to break. The Sherman never breaks. You start it, drive it, stop it, and it performs consistently day after day. For a driver, this reliability is worth more than any performance advantage. You can focus on fighting instead of nursing a sick machine. By February 1945, the testing program had accumulated comprehensive data. The EZ-8 had been driven over 1,500 kilometers, subjected to hundreds of firing trials, operated in temperatures ranging from -15 to +10 degrees Celsius, and pushed through terrain that would challenge any tank. Throughout this abuse, it required minimal maintenance. One track was replaced due to wear. Engine oil was changed at prescribed intervals. A few rubber track pads were swapped out. Nothing broke. Nothing failed. The suspension components showed no measurable wear. Compare this to German tank experience. A Panther driven 1,500 kilometers would typically require final drive replacement, transmission repairs, multiple track adjustments, cooling system maintenance, and various smaller fixes. A Tiger would need similar attention. The disparity in maintenance requirements represented a strategic advantage as valuable as superior armor or firepower. American tank units could maintain high operational readiness with limited maintenance support. German panzer divisions saw their effective strength erode rapidly as mechanical failures accumulated faster than repairs could be completed. Franz Weber compiled a comprehensive comparison of maintenance requirements that laid bare the operational cost of German engineering sophistication. To maintain a Panther battalion of 45 tanks in combat operations requires approximately 200 maintenance personnel, substantial stocks of specialized tools, mobile workshop facilities, and constant supply of spare parts for complex components. The failure rate averages 30 to 40% of tanks non-operational at any time due to mechanical problems. An equivalent American Sherman battalion with EZ-8 tanks requires approximately 120 maintenance personnel, mostly using basic tools, minimal workshop facilities, and simplified spare parts inventory since most repairs involve replacing complete assemblies rather than complex teardowns. American operational readiness averages 85 to 90% even during sustained combat. The difference of 50 to 60% operational readiness is strategically decisive. It effectively means German panzer units fight at half strength, while American armored units fight nearly at full strength. No amount of technical superiority in individual tank performance can overcome this disparity in available combat power. The reports from Kummersdorf circulated through what remained of German military technical bureaus during early 1945. Many officers and engineers who read them recognized that the EZ-8 represented a culmination of lessons Germany should have learned years earlier. Operational reliability mattered more than peak performance. Maintainability was more valuable than sophistication. Design simplicity trumped engineering complexity in sustained warfare. These principles had been demonstrated repeatedly as American equipment consistently outperformed German equivalents in operational availability, despite often inferior specifications. Yet changing German tank development to incorporate these lessons was impossible by early 1945. The industrial infrastructure was collapsing under bombing. Material shortages constrained production. Skilled workers had been drafted or killed. Even if German designers had wanted to create simpler, more reliable tanks, the capability to do so no longer existed. The knowledge came too late to matter for Germany's fate, serving only as documentation of opportunities missed and principles ignored. General Heinz Guderian, still serving as Chief of the General Staff despite the hopeless strategic situation, received detailed briefings on the EZ-8 evaluation. According to staff notes from a meeting on February 9, 1945, Guderian commented that the American suspension system represented exactly the kind of practical engineering Germany needed but could never implement due to institutional resistance to simple solutions. "Our designers always pursue perfection through complexity," Guderian reportedly said. "The Americans achieve adequacy through simplicity. In total war, adequacy produced in vast quantities defeats perfection produced in small numbers." The philosophical dimension of the EZ-8's superiority troubled German engineers more than the technical specifics. The HVSS suspension wasn't revolutionary. It used proven components, straightforward design principles, and manufacturing techniques readily available to any industrial nation. There was no secret technology, no advanced materials, no breakthrough innovation. The Germans could have designed an equivalent system in the 1930s if their engineering culture had valued practical effectiveness over technical sophistication. The horizontal volute springs were simply large coil springs oriented horizontally instead of vertically. The trailing arm suspension geometry was well understood. The wider tracks were obvious solutions to ground pressure challenges. Everything about the HVSS was conceptually simple, yet German designers, trained in a tradition that equated complexity with quality and sophistication with superiority, never pursued this approach. They assumed that engineering excellence required elaborate solutions to achieve optimal performance. The EZ-8 proved that engineering excellence could mean simple solutions that worked consistently under all conditions. Dr. Fleischer's final report, dated February 28, 1945, attempted to articulate this cultural distinction. German engineering tradition emerges from a philosophical framework that views mechanical design as applied science pursuing theoretical perfection. We design for optimal performance under ideal conditions and accept that field service will inevitably compromise this performance. American engineering tradition emerges from a pragmatic framework, viewing mechanical design as problem-solving for real-world conditions. They design for adequate performance under worst-case conditions and accept that theoretical optimization is sacrificed for practical reliability. Neither approach is inherently superior in abstract terms. Both can produce excellent results within their respective contexts. However, the conditions of modern industrial warfare decisively favor the American pragmatic approach. Wartime operations occur under field conditions, not laboratory conditions. Equipment must function when maintained by exhausted soldiers with limited tools and training, not by specialist technicians in ideal workshops. Designs must accommodate imperfect materials and variable manufacturing quality, not assume perfect inputs. The EZ-8 suspension exemplifies design principles optimized for wartime reality. Our Panther suspension exemplifies design principles optimized for peacetime idealism. The testing of Lucky 7 continued until mid-March 1945, when fuel shortages effectively paralyzed most operations at Kummersdorf. Soviet forces were approaching from the east. American forces pushed toward Berlin from the west. Germany's collapse was imminent and obvious, yet engineers continued documenting the EZ-8's characteristics with professional thoroughness, perhaps recognizing that this knowledge might somehow matter beyond the immediate catastrophe. The tank's ultimate fate remains unclear. Some reports suggest it was destroyed during Soviet bombardment of Kummersdorf in April 1945. Other accounts indicate it may have been captured by Soviet forces and evaluated briefly before being scrapped. The documentary evidence ends in mid-March. Lucky 7 disappeared into the chaos of Germany's final collapse, its specific fate lost among millions of other wartime tragedies and confusions. But the impact of its testing survived in the detailed reports and analyses that German engineers produced. These documents, captured by Allied forces after the war, provided fascinating insights into how German technical professionals viewed American equipment. The assessments were remarkably objective, largely free from propaganda and national pride. German engineers recognized superior design when they encountered it and documented their findings honestly, even when those findings contradicted cherished assumptions about German technical supremacy. The EZ-8 represented evolutionary rather than revolutionary development. American tank designers had identified problems with the original Sherman suspension, poor cross-country mobility due to narrow tracks, inadequate ride quality affecting crew performance and gunnery, maintenance complications with the vertical volute system. They solved these problems through straightforward engineering: wider tracks, horizontal springs, simplified geometry, nothing exotic, nothing requiring technological breakthroughs, just competent application of proven principles. The result was a significantly improved tank that remained simple to manufacture and maintain. German designers might have followed the same path if institutional culture had permitted it. The problems with interleaved road wheels were well known. Engineers understood that complexity created maintenance burdens. Combat reports consistently highlighted operational reliability as critically important. Yet German tank development continued pursuing sophisticated solutions because the entire design establishment was built around that approach. Changing direction would have required admitting that simpler was often better, a philosophical concession that proved impossible for an institution that defined excellence through technical sophistication. The post-war assessment of the EZ-8 by military historians and tank experts consistently rated it as one of the most effective medium tanks of World War II. Not the most powerful, not the best protected, not the fastest or most advanced, but among the most effective when all factors were considered: firepower, protection, mobility, reliability, maintainability, producibility, crew effectiveness, and operational availability. The HVSS suspension was critical to this overall effectiveness, enabling the mobility and crew performance that made the EZ-8 formidable, despite its modest specifications. Modern tank designers study the EZ-8 as a case study in balanced design. Contemporary main battle tanks attempt to combine German-style firepower and protection with American-style reliability and maintainability. The ideal is a sophisticated system that functions dependably under field conditions. Achieving this synthesis requires conscious effort to resist the natural engineering tendency toward complexity for its own sake. The EZ-8 serves as a reminder that simple, robust solutions often outperform elaborate alternatives in practice, even when theoretical analysis suggests otherwise. The captured EZ-8 at Kummersdorf taught German engineers lessons that German industry could not implement during the war, but that influenced post-war German engineering philosophy. The German automotive industry that emerged after 1945 became renowned for combining quality with reliability, sophistication with dependability. This represented a synthesis of pre-war German emphasis on technical excellence with hard lessons learned about operational consistency during the war. The EZ-8 was one of many data points that forced this philosophical evolution. For American tank designers, the EZ-8 validated their developmental approach. They had identified specific problems with the M4A3, addressed those problems through straightforward engineering solutions, and produced a significantly improved vehicle without disrupting production or introducing excessive complexity. This incremental improvement methodology, refining existing designs rather than pursuing radical innovations, proved highly effective for wartime conditions. It kept production lines running while steadily improving capability. The suspension technology itself became influential beyond the Sherman. The HVSS principle of horizontal springs and trailing arms influenced post-war tank suspension design worldwide. Modern tanks use various suspension systems, torsion bars, hydropneumatic units, hydrogas systems, but the underlying principle of independent wheel stations with robust damping reflects lessons the EZ8 demonstrated. The interleaved road wheel concept largely disappeared from tank design, relegated to historical curiosity, its maintenance problems ultimately outweighing its performance benefits. The story of Lucky 7 and its evaluation at Kummersdorf represents a broader pattern in World War II. German recognition of American industrial and engineering capabilities coming too late to influence outcomes. By late 1944, German engineers understood clearly that American industry had mastered mass production of effective military equipment. German reports consistently acknowledged American superiority in producing vast quantities of adequate equipment rather than small quantities of sophisticated equipment. This recognition didn't change strategic realities because Germany lacked the industrial capacity and resources to match American methods. The psychological dimension was perhaps most significant. German national identity and Nazi ideology were built partly on assumptions of German technical superiority. The narrative that German engineering excellence would overcome material disadvantages was central to maintaining morale and justifying continued resistance. Testing captured American equipment systematically undermined these assumptions. The EZ8 wasn't better because Americans were more intelligent or more capable. It was better because American industrial culture prioritized different values: practicality over perfection, reliability over performance, simplicity over sophistication. These values produced more effective equipment for modern warfare. German engineers who tested Lucky 7 couldn't ignore the evidence before them. The American suspension worked better under field conditions than German equivalents, despite being conceptually simpler and less sophisticated. This forced uncomfortable conclusions about the relationship between technical complexity and military effectiveness. More advanced didn't automatically mean more effective. Greater sophistication didn't guarantee superior results. Sometimes, often actually, simple and robust beat complex and delicate. These lessons transcended tank suspension design, applying broadly to engineering philosophy and industrial practice. In any complex endeavor, there's natural tendency to pursue optimal solutions through elaborate means. The EZ8 demonstrated that adequate solutions through simple means often produce better outcomes in practice. This principle applies to software development, business processes, organizational structures, and countless other domains. Operational consistency usually matters more than peak performance. Reliability under stress typically trumps capability under ideal conditions. The German testing of the EZ8 stands as historical testament to professional integrity under difficult circumstances. Engineers at Kummersdorf could have produced reports confirming German superiority and dismissing American capabilities. Instead, they documented objective reality. The American tank was better in ways that mattered strategically. Their reports were models of technical analysis, free from ideology or nationalism, focused on facts and implications. This intellectual honesty came too late to help Germany, but serves as example of professional commitment to truth over comforting falsehoods. The captured Sherman M4A3E8, abandoned during the Battle of the Bulge and tested exhaustively at Kummersdorf, ultimately represented something more than just a tank with improved suspension. It embodied a complete design philosophy that German industry could comprehend but not replicate. Mass production of reliable equipment triumphed over limited production of sophisticated equipment. Practical effectiveness defeated theoretical perfection. Simple solutions consistently implemented overcame complex solutions inconsistently achieved. These weren't lessons Germany could have learned earlier and implemented to change outcomes. German industrial structure, design culture, resource constraints, and political leadership all constrained development in directions that made American-style pragmatism impossible. The EZ-8's superiority wasn't something Germany could have copied. It emerged from fundamental differences in industrial capability and engineering philosophy that ran too deep to change during wartime. Yet the testing at Kummersdorf documented these differences with scientific precision. German engineers measured, analyzed, and reported exactly how and why the American suspension worked better than German equivalents. Their conclusions were unambiguous. The HVSS suspension represented superior engineering for wartime conditions, not superior in theoretical performance, not superior in technical sophistication, but definitively superior in operational effectiveness, maintainability, and contribution to overall tank capability. The horizontal springs, the trailing arm geometry, the independent bogies, the wider tracks, all these elements combined to create a suspension system that kept tanks mobile, kept crews effective, kept guns stable, and kept maintenance requirements minimal. In doing so, the EZ-8 demonstrated that victory in industrial warfare belongs not to those with the most advanced technology, but to those who most effectively apply adequate technology at decisive scale. Thank you for watching. For more detailed historical breakdowns, check out the process and other videos on your screen now, and don't forget to subscribe.